never good. In the 20th century, tens of millions of people lost their lives. Ironically, amidst the carnage, disease, and pain of war, have emerged some of history's greatest inventions, including revolutionary developments in communication, transportation, and medicine. So many of our everyday items were developed during war that it leaves people wondering about the controversial role war plays in a society's technological advances.
Wars serve as a pressor function, an accelerator to bring things from research to utilization much more quickly.
Technology tends to move forward in wartime because you're in the ultimate competition. If the other guy competes and you don't, you die. That's a strong incentive to compete. Funds that would otherwise not be available become available. People stop worrying about the budget because the outcome is more important than the cost. The whole society becomes mobilized. One of the most remarkable things is how much of what we take for granted in our everyday life came out of top secret military developments that were often war-winning technologies.
Yes, wars have given us products we use on a day-to-day basis that we're not even aware of. Like plastics. It would be hard to imagine life today without these carbon-based synthetic materials. Molded into countless shapes and objects, the plastics industry is a $300 billion a year business. Scientists actually invented several of the modern thermoplastics just prior to World War II. Some plastics sat on the shelf, waiting to find a purpose for their existence. Others, such as nylon, found an immediate market. DuPont unveiled the miracle fiber nylon to an enthusiastic crowd at the 1939 World's Fair. The DuPont representative declared nylon to be stronger than steel. Although the demand for nylon stockings was high, people had yet to realize the true potential of plastics. But as war broke out, the miracle material was about to give the Allies a leg up. The war effort sent chemists back into the lab and back into the vault to find new uses for plastics. In the early 1940s, researchers discovered that plastics such as nylon could be molded into a variety of shapes.
So suddenly, if you could release a pound of steel or a pound of aluminum, replace it with nylon, you could build another tank, you could build another gun, you could build something which had to be made of a strategic metal. Plastic was looked to more and more as the war went on as a substitute for metal.
Researchers found new uses for existing plastics. Manufacturers used nylon for parachutes, parachute cord, and airplane tires. Engineers substituted vinyl and polyethylene for rubber. The plastics industry generated millions of tons of materials during the war. When the war ended, manufacturers introduced plastic items from hairbrushes to Tupperware, ushering in the synthetic century. Dispensing everything from paint to shaving cream, aerosol cans make life easier. The spray can utilizes a low-pressure propellant, but it was invented under high-pressure conditions. That convenient aerosol container was originally designed to save lives. During World War II, U.S. troops in the Pacific battled an enemy that was almost as dangerous as the Japanese: mosquitoes. Mosquitoes transmitted malaria, eventually infecting 124,000 troops in the Pacific Theater. In 1942, Dr. Lyle Goodhue of the U.S. Department of Agriculture struggled to find a solution. He combined a propellant gas and insecticide in a metal cylinder, then attached a simple nozzle. The first aerosol can was designed to kill insects, not body odor. Before war's end, Goodhue left the Department of Agriculture and started his own company in Neodesha, Kansas, to make aerosol cans for the fight against mosquitoes.
Crown Cork and Seal was a can manufacturer. They were approached with the idea of making an aerosol can, and what they had done was take a beer can production line and modified it to generate the first aerosol cans. That can was called the spray tainer, a unique name for the product because it was a can that was used to spray product out, something that never happened before.
Soldiers used the aerosol company's cans to kill insects in tight quarters. Malaria cases dropped dramatically, thanks in part to the cans known as bug bombs. After the war, companies introduced every imaginable product in a can. People fell in love with the spray can. But scientists discovered in the 1970s that CFC, chlorofluorocarbon propellants, contributed to the depletion of the ozone layer. When CFCs reach the stratosphere, the molecule is broken down by ultraviolet radiation. This releases chlorine atoms, and chlorine is what destroys ozone. In 1978, the U.S. demanded replacement of aerosol CFC propellants, making them more environmentally friendly. Today, the majority of aerosol cans use hydrocarbon propellants. War changed even the food we eat. Before preservatives, most foods wouldn't last more than a week. But one great war leader asked, can it?
Napoleon once said that armies moved on their stomach. And if you look back over the history of warfare, the two things that have aborted more campaigns and destroyed more armies than any of the weaponry they faced were disease and failure of food supplies.
Food spoilage on long military campaigns was such a problem that in 1795 the French government offered a 12,000 franc prize to anyone who discovered a new way to preserve food. Until then, armies relied on pickling or drying. Both altered the taste, and still the food spoiled. A French chef, Nicolas Appert, accepted the challenge. After 14 years of experimentation, he discovered that by first sealing food in glass bottles, then boiling the jars for several hours, shelf life increased dramatically. In 1809, he won the award and began supplying food to the army. Appert's method worked because boiling killed the bacteria within the containers. A year later, Peter Durand in England patented the first tin can, which held up better than glass bottles. The Royal Navy was soon buying tinned food. Meet Dr. Edwin Moore, one of the men who made orange juice synonymous with breakfast.
When I was a kid, you had oranges perhaps at Thanksgiving or Christmas. Later on, you had canned orange juice. But as I always thought, boy, you can always improve on canned orange juice. Unfortunately, oranges are seasonal and perishable. But they are also a rich and excellent source of vitamin C. As World War II broke out, there was big concern about the age-old disease of scurvy caused by the lack of vitamin C. The U.S. government appealed to the Florida Citrus Commission to find a solution. Donald Atkins, Lewis Gardner McDowell, and Edwin Moore searched for a way to get the essential nutrients to the soldiers and civilians who needed it overseas. The scientists wanted to create a good-tasting product that wouldn't spoil. Near the war's end, they perfected frozen concentrate orange juice. Dr. Moore and his associates reduced the water content in juice by applying low heat in a high vacuum. They then added fresh juice to the concentrate for taste. Finally, they froze the mixture. When Moore reconstituted the frozen concentrate with water, he thought it tasted like fresh juice. But the true test came at the yearly Orange Festival. Atkins and I made concentrate.
And the Citrus Commission had a booth at the Florida Orange Festival. And we were demonstrating how it was made, how it was reconstituted. It had the vitamin content and all. And we had one of these books out to sign, you know, with the comments. And the comments of 5,000 people was, "This tastes just like fresh juice. When will we be able to buy the product?" So right then we knew we had something.
Almost overnight, a new industry was born. Farmers rushed to plant orange groves. In the 1950s, orange juice became available on breakfast tables year-round. Florida produces more than 1.5 billion gallons of orange juice a year. In a rush to get somewhere? Next, see how war got the wheels of progress rolling and altered transportation forever. American Ezra Warner invented the tin can opener in 1858, nearly 50 years after the invention of the tin can. Inventions of War will return on Modern Marvels. We now return to Inventions of War on Modern Marvels. Among the many innovations of war, few have rolled into civilian life as smoothly as those involving transportation. With the luxuries of CD player and air conditioning, the Jeep is at home, off-road, or in town. The ancestor of today's Jeep Wrangler was a true workhorse and decorated war hero of World War II.
General Eisenhower, at the end of the war, summarized it, said there were 3 weapons that were decisive. The Jeep was one of them.
On the eve of World War II, the U.S. government, desperate for a general-purpose vehicle, requested submissions from various car companies. The government chose the American Bantam Car Company's design, a lightweight, 60-horsepower, 4-wheel drive vehicle with a top speed of 65 miles per hour. After grueling tests, the Army fell in love. Soldiers first shortened General Purpose to GP, or Jeep. The name stuck, but the vehicles rarely did. The demand was so high that the government asked other companies to produce Jeeps.
It enabled our troops to go mechanized anywhere that the enemy was. We didn't have to rely on foot power. The Jeep was used as a reconnaissance vehicle. In the desert and elsewhere, it was armed and used as an assault vehicle. It was used for cargo, it was used for medevac. There were more than 400,000 of them made.
The Jeep became a much-loved symbol of World War II. After the war, Jeep manufacturers continued making them. Today, Daimler Chrysler sells 84,000 Jeeps a year. During war, a country's natural resources are among its greatest assets. The United States is fortunate with abundant reserves, from steel to petroleum. But at the beginning of World War II, the U.S. was caught off guard by one severe resource shortage. A resource without which the U.S. would have no hope of winning the war.
Rubber was, after steel, probably the most important strategic material for fighting World War II. And the reason for that was that it was the first truly mechanized war. Machines had to be mobile. It was the most mobile war in history.
In the 1930s, aware of Germany's limited natural resources, Hitler made developing synthetic rubber a top priority. German scientists created a petroleum-based synthetic rubber called Buna. The U.S. military, confident their supply of natural rubber from Singapore was secure, delayed development. 2 months after Pearl Harbor, however, the Japanese captured Singapore. The sudden loss forced the nation into its first real resource emergency.
Here are 2 simple rules for this rubber emergency. First, turn in all the old rubber. Secondly, cut the use of your car.
Tires, they're humble items, but without them trucks don't roll, and if trucks don't roll, the tanks don't have gas, and the soldiers don't have food.
Rubber recycling alone couldn't keep the war machine rolling. By 1942, the U.S. was desperate for rubber. Former rivals, professors and chemists, banded together to work on a solution. Soon, scientists found a synthetic rubber chemical concoction suitable for molding into tires. The government rushed to construct 50 synthetic rubber plants. Tire production soared. In 1944, plants generated more than 800,000 tons of synthetic rubber, far more tires than they were producing before the war from natural rubber, inflating America's confidence once again. After the war, tire companies continued manufacturing synthetic rubber. Today, American tire companies combine 60% synthetic and 40% natural rubber to make tires. While working on the rubber problem, an American chemist came up with a truly silly solution.
A contract was given to GE to try to come up with its own form of synthetic rubber, if they could, and GE assigned one of its top polymer scientists by the name of James Wright to work on the synthetic rubber problem. They came up with a very rubber-like compound, which they called nutty putty, but it had none of the resilience of a true synthetic rubber, and GE used it as a novelty. It was given out as kind of gifts among GE executives. It was kind of a joke.
But GE chemists loved taking nutty putty to cocktail parties. At one particular event, Ruth Falgotter, a toy store owner, noticed the fun people were having with the pink blob and decided to include it in her holiday toy catalog. That season, the novelty sold well, but she didn't see a future in it. However, one of her associates did. Peter Hodgson bought a large batch of the goo from GE, packaged hand-sized globs, and dubbed it Silly Putty.
And he came up with the brilliant notion of the plastic egg to put the silly putty in, and the rest is novelty history.
Binney and Smith, the makers of Silly Putty, have sold more than 300 million of the eggs since 1950. Over 1.6 million people travel by plane in the U.S. every day. The turbojet engine revolutionized the way we travel, reducing the duration of a transatlantic crossing to a couple of cocktails and a movie. But coach seating and airline meals wouldn't be the same today without the research done in the shadow of an impending war. Both Germany and England simultaneously worked on the jet engine before World War II. Turbojet engines work by compressing air in the firing chamber, injecting atomized fuel and igniting the mixture, propelling the vehicle forward. In August 1939, Germany got their jet program off the ground with the HE-178, the world's first jet aircraft. The far superior Me-262 fighter jet soon followed.
It was a world beater. It would go almost 600 miles an hour at a time when propeller aircraft were doing well to do 450. Nothing could stop it except Adolf Hitler, and I think we're all fortunate that Hitler was a meddler. He thought it would make a great bomber. So he instructed the Luftwaffe to hang 2 bombs under it, which slowed it down to about 400 miles an hour under the top speed of our fighters so we could catch it. By the time they got around to saying, yes, let's use it as a fighter, it was 1945 and the war was lost.
After the war, England and the U.S. continued developing military and commercial jet aircraft. The British introduced the first commercial jet airliner, the de Havilland Comet, in 1952. Boeing's answer to commercial jet transportation was the 707.
Now the Boeing 707, which became the 737 and led to all the other ones, was basically a rebuilt Boeing B-47 bomber that was developed in the late 40s to be our first strategic jet bomber. The way the engines were hung off the wings, the tail grouping, the pressurization to keep cockpit pressure, all those things were pioneered on the B-47, enhanced in the B-52, which came very shortly thereafter, and then led immediately to the 707.
War did more than shorten distances. In some ways, it brought us closer together. In other ways, it propelled us farther away, taking us places we've never been before. Military engineers predict the use of the B-52 bomber will extend beyond 2045, a lifespan of more than 100 years. Modern Marvels will return. We now return to Inventions of War on Modern Marvels. Some inventions of war have found everyday applications that are sometimes seen as a blessing and a curse. Like radar. In the first part of the 20th century, researchers discovered they could detect flying objects with electromagnetic waves. By transmitting radio signals, metallic objects reflected the signals back to the transmitter. Engineers called the invention radar, for radio detection and ranging. Serious radar work began in the 1930s. The British, fearing a future air war, put their top engineers on it. By 1938, England had the world's first practical radar system.
The possession of an effective radar chain in 1940 was probably the single most important technological advantage that the British had.
England's pre-war anxieties were prophetic. Between August 1940 and May 1941, the Luftwaffe pummeled England with bombs during the Battle of Britain.
What the radar chain did was give them the crucial advance warning. By 1940, the radar chain could look into northern France, and you could see the German raids forming up over northern France, and you could deduce their strength, their direction, and you could employ the fighters who would always be outnumbered in the most advantageous way.
Radar research led to another invention that we see as indispensable today. During the war, a British radar researcher created the cavity magnetron. The device generated shorter waves, or microwaves, that made radar much more accurate. Carefully transported to the United States for large-scale duplication, Percy L. Spencer, a Raytheon engineer, worked to further improve the cavity magnetron. One day in 1945, Spencer was standing in front of a magnetron tube when he noticed that the candy bar in his pocket inexplicably had melted. Wondering if the microwaves generated by the magnetron did the cooking, he placed kernels of popcorn beside it. They popped, and leftovers would never be the same. In 1947, Raytheon demonstrated the Radar Range, the world's first microwave oven. It was the size of a refrigerator and cost between $2,000 and $3,000. Many credit radar as saving England, as well as a few inept cooks. But the World War II invention is still helping save lives by keeping track of air traffic and watching the weather. It's even mapping the surface of Venus. Although some war innovations have a tendency to bring us down, others lift us higher than we've ever gone before.
5, 4, 3, 2, 1. Liftoff. We have a liftoff. 32 minutes past the hour.
A rocket is a means of delivering a payload to a specific destination, whether that's the moon or the Soviet Union. Rockets trace their origins to the experiments of Dr. Robert Goddard. the U.S. scientists launched the first liquid-propelled rocket in 1926. Independently, a group of rocket enthusiasts began similar work in Germany. Germany in the 1930s was a volatile place. Many Germans felt the Treaty of Versailles, signed at the end of World War I, was unfair. It limited the country's military and blamed Germany for causing World War I. Adolf Hitler rose to power by playing on the German people's feelings. The German military soon showed interest in the rocket group's work.
This was in effect a loophole. There was no direct ban on rocket research because, of course, the people that drew up the Versailles Treaty knew nothing about rockets and didn't anticipate rockets becoming a weapon.
Realizing the potential, the military constructed a rocket testing facility and made Werner von Braun project director. Von Braun's team developed the most impressive rocket of its day, the V-2. The V-2 burned alcohol and liquid oxygen fuel and carried a 1-ton warhead. Germany terrorized England by launching more than 1,100 V-2s at London, killing 10,000 people. Fortunately for the Allies, it was too late to turn the tide of the war.
After the war, we and the Russians both captured a large number of these rockets and used them for initial tests, not just for military purposes, but for launching satellites and high-altitude probes. We kept refining the design, improving it. The moon rockets were basically really overgrown V-2s. Germans' innovations led to the space race for both war rockets, ICBMs, and for satellite launchers, and initially they were the same thing.
No war invention changed the world more than the atomic bomb. Harnessing the same power that destroyed Hiroshima, nuclear energy provides a significant portion of the world's power needs today.
Despite the fact that commercial nuclear power is derived from the research leading to the bombs that were dropped on Hiroshima and Nagasaki, there's really very little connection between nuclear power plants and bombs. Nuclear power, I consider to be a very attractive way to produce electricity commercially because it's so clean. It is an extremely safe technology.
Most modern nuclear energy plants generate power by uranium fission. A chain reaction occurs when a neutron is fired into a uranium-235 atom and splits it. At the same time, this releases other neutrons that split other uranium atoms, generating a great amount of thermal energy. In the core, the heat creates steam, which turns traditional turbine generators, producing electricity. The history of nuclear power dates back to the Second World War. Physicist Enrico Fermi initiated the first sustained nuclear reaction at the University of Chicago in December of 1942.
Shortly thereafter, Fermi and a number of the very prestigious members of his team began having a series of meetings, some of which were directed to determining how this new concept could be applied to the generation of electricity for our civilian commercial needs. In some sense, the groundwork of the nuclear power system that we have now in this country was laid at that time.
After the war, atomic research continued. Scientists searched for a peaceful use of the atom. And in 1958, America's first commercial nuclear power plant powered up. Currently, the U.S. operates 104 nuclear plants, generating 20% of the nation's power. The fissioning of 1 pound of uranium is roughly the equivalent of burning 3 million pounds of coal. Of course, there are also negative aspects of nuclear power. Although it is sometimes reprocessed, spent uranium fuel is highly radioactive and remains so for thousands of years. People view this war invention differently: a catastrophe waiting to happen, or a viable solution to diminishing fossil fuel reserves. In the course of your day, some war inventions help us cope with the dangerous world away from the battlefield.
Oh, yeah, no, I heard it. No, I heard it.
Next, war inventions designed to save lives. Medicines, miracle cures, and magic bullets. 84% of American households own a microwave oven. Inventions of War will return on Modern Marvels. We now return to Inventions of War on Modern Marvels. One of man's objectives in war is to kill the enemy and save as many of his own troops as possible. From the horrific wounds and disease of war have come major medical advancements. Often overlooked are the medical advancements made during the deadliest war in American history, a war that cost more American lives than both world wars combined.
Major seeds of modern medical practice began in the Civil War and have continued to develop at a rapid state ever since. For example, the creation of an ambulance system may have been the greatest advancement of all. How to get a wounded man from the battlefield to a first aid station. It seems so logical to us. It didn't exist at that time.
At the beginning of the Civil War, there were many problems with evacuating injured soldiers from the battlefield. The soldiers who were assigned to operate the rickety ambulance carts were often those who were not suited or willing to fight. Devastating battles left thousands injured. Those who couldn't move might lay for days before help arrived. Often, that was too late. Identifying the problem, Jonathan Letterman, a medical director with the Union Army, established an ambulance corps. Under his system, soldiers were assigned to systematically collect the wounded and transport them to field hospitals. The ambulances also carried a prescribed list of medical supplies. After the war, civilian hospitals adopted Letterman's system. The crisis of war provides a proving ground, a lab where new drugs and techniques are tested. Many times on the battlefield, bullets aren't what kill people.
Right here? A little lower.
In all wars through the 19th century, it was expected that 2 or 3 times the number of people would die of disease than died of enemy action.
One of the big killers was typhoid fever. The disease, caused by the Salmonella typhi bacterium and transmitted through contaminated food or water, was fatal to 30% of the people who contracted it. In the late 1800s, English bacteriologist Almroth Wright discovered a vaccine to prevent typhoid. Wright proposed mandatory inoculation of all soldiers fighting in the Boer War. Not trusting the science, many objected and refused vaccination. Only 14,000 troops received the typhoid vaccine. The results were catastrophic for those who refused vaccination. 1 out of every 6 soldiers developed the disease, and 9,000 died.
In 1898, the United States went to war with Spain, and there was a rapid mobilization of volunteers. In the training camps of that war, typhoid fever epidemics broke out. Hundreds died, thousands were sick before they ever got to the enemy. People are not supposed to die before they get to the enemy.
The U.S. learned from the English. The U.S. Army developed their own typhoid fever vaccine.
In 1911, immunization against typhoid fever became standard policy and is only the first of many of the constructed immunizations that we use to protect soldiers, sailors, airmen, and Marines to this day.
By World War I, the incidence of typhoid dropped from 10% to 2%. During World War II, the battle against disease-causing microorganisms saw an innovation that has saved more sick and injured than any single invention in history.
Penicillin, the magic bullet. From ancient times, doctors and patients had dreamed of a drug that would make people well, almost miraculously. In the 1920s, Alexander Fleming serendipitously discovered that the mold, penicillin, produced a juice that would kill other organisms. Antibiosis, anti-life.
Fleming published his work but was never able to purify penicillin nor produce it in mass quantities. It was forgotten for a decade. World War II, however, provided new incentive for finding a drug that cured infection. Scientists Howard Florey and Ernst Chain, working in England, continued Fleming's research. They came up with a purified penicillin injection. Limited human testing hinted at the miraculous effects of penicillin, but the war prevented them from producing enough of it to benefit many people. With the fate of millions in their hands, they turned to America. Ernst Chain secretly carried the miracle mold to the United States.
It was almost the equivalent of the Manhattan Project in the effort to get penicillin in sufficient quantities to take care of all the soldiers wounded. The National Research Council convened pharmaceutical executives and said, "We have a problem. We need you to cooperate. Share your data, and let's figure out a way to make this drug, this magic bullet, available now."
After an exhaustive search to find the perfect mold, scientists discovered a method to produce penicillin in larger quantities. Thousands and later millions benefited.
America is continually increasing its output of penicillin, the new drug that effects almost miraculous cures.
By the end of the war, the magic bullet has been found. An infectious bacterial disease looks like it's been conquered.
Next, see what innovation sprang from the mere threat of war. Hot products from a Cold War. In 1943, the United States produced 28 pounds of penicillin. In 1945, production increased to 14,000 pounds. Inventions of War will return on Modern Marvels. While war is about tearing the enemy apart, it has connected others. Even desktop computers trace their origins to the giant machines developed during World War II. The U.S. built ENIAC to quickly calculate cannon trajectory charts. The monstrous computer utilized 18,000 vacuum tubes and generated an enormous amount of heat. Although it took up 1,500 square feet, it could only operate for a few minutes before blowing a vacuum tube. It also had less computing power than a modern handheld computer. The heat of battle has always bred innovation, but it was a colder environment that fueled major advancements during the second half of the 20th century. The Cold War ignited an arms race and a race for space. The United States and the Soviet Union spent trillions of dollars to stay ahead of the other.
The Cold War really began seriously when the Soviets exploded their first nuclear weapon, and then just a year after us exploded their first hydrogen weapon.
As the stakes got bigger, technology got smaller.
We went from the tube technology to the transistor technology to the chip technology, all driven by the military's need to shrink things down, reduce their weight, and improve their reliability.
In 1957, the Soviet Union launched Sputnik, the world's first artificial satellite, and lifted the competition between superpowers to a new level. It was a milestone for the Soviets and a wake-up call for the United States. Americans were left feeling U.S. technology lagged behind that of the Russians.
The Soviet launching of Earth satellites is an achievement of the...
In response, President Dwight Eisenhower established the Advanced Research Projects Agency. ARPA, to stimulate military science and technology research. During the 1960s, ARPA worked with many institutions, each using different computer systems and software. The agency started working on a way to connect everyone. ARPA later became DARPA when the word defense was added to the name.
DARPA essentially committed to build a very small-scale network for research purposes. The motivation was actually efficiency within the DARPA research community, make it possible to share resources more effectively so that if one institution needed resources that you could access over the network at another institution, you wouldn't have to replicate them everywhere. You could share computer software from one place to another without having to recode it.
By 1969, the first 4 nodes of the ARPANET were successfully connected.
They were all linked together with 50 kilobit per second lines that were leased from AT&T, and the network itself became a tool for building a community of people that could both communicate with each other online, share their research and knowledge, and essentially build a stronger capability for the country in virtually every dimension. And of course, eventually this became the springboard for what became the Internet.
Military spending is $300 billion a year, with $38 billion spent on research. But what happens when the country's greatest foe stops swinging?
When the Cold War ended and both sides decided to stand down from their level of hostility, a lot of manufacturers who made war weaponry had to look for other markets. A company in Utah that manufactured solid fuel for nuclear missiles converted that technology to make propellant for automobile airbags. So it's almost biblical, swords into plowshares. This is exactly what we are doing. We're taking the most awesome military technology and converting it not just for civilian use, but for life-saving civilian use.
Although the U.S. hasn't been involved in a world war for over 50 years, war and the threat of war has significantly affected our peacetime lives.
It is an interesting commentary on the nature of humanity that it took something as dreadful as war to force forward many of these technologies and developments and new techniques. But that seems to be the nature of historical change. There's no question that the world we live in would have been different, probably much less comfortable, possibly much less safe.
Examine the paradox. The world needs war to make peacetime truly safe. But is that really true? Or does war do just the opposite, draining vast resources, wasting technology and lives, channeling research along narrow paths of destruction, and retarding growth in other areas? If the planet had enjoyed a peaceful 20th century, who knows where we might be today? Who knows what the inventions of peace might be? As we contemplate those questions, however, we may as well make the most of the many inventions of war that have filtered into society, helping us navigate everything from the interstate to the internet.